Hello, this is a problem from chapter 2. It's chapter 2, number 59, and it's a problem where the water is dripping out from the shower nozzle, and we're trying to figure out how far below the shower nozzle is each drop. And so first we want to draw our situation. We're told that water is dripping from the nozzle onto the floor 200 centimeters below. Typically it's a good idea to use meters instead of centimeters, and so we know that that equals 2 meters. The drops fall at a regular interval of time. The first drop striking the floor at the instant the fourth drop begins to fall. So I'm going to draw that. Here's my 2 meters. And then I have 4 drops. So 1, 2, 3, 4. This is not to scale whatsoever. We know that they're not necessarily equal distances apart. They won't be. They're equal times apart. But since we're not sure about the distances, we can just sketch it out like this. Now, it's important, however, to recognize that it tells us the first drop strikes the floor at the instant that the fourth drop begins to fall. So that means that this one right here is the first drop, and this one right here is the fourth drop. Now that is mainly important because we are going to be solving for the second drop and the third drop, and if you don't know which one is the second and the third, then that makes it difficult. So this one, of course, would be the second, that one would be the third. And we want to know how far below the nozzle each of those are. So first what I want to do is I want to solve for the total time. Now I'm going to call this location right here, this is my x naught because that's where I'm starting from. And I could consider it to be 2 meters and then this would be 0, or I could consider this to be 0 and that's going to be -2 because we know that up is a positive direction. That's what I'm choosing for this one. As long as you set your 0 to be some constant location, then that's fine. I'm going to call this 0 for now, and you'll see why in a little bit. So we're solving for our time here. So my final x position is going to be -2, because we're 2 meters below where we started, minus 0 equals my initial velocity. Fortunately, we also know that that is going to be equal to 0 because we're dropping it from rest. So that's a 0 initial velocity. So 0 times time is 0 plus 1/2. My acceleration is -9.8 because again I chose up to be positive, so that's going to be a negative value. And then we're solving for this time. So if you solve for this time, you'll find out that your time equals 0.6388 seconds. And so that's the entire time for this first drop to fall. Now, it's fortunate for us that we have this picture so we can figure out exactly the different time intervals, because I noticed that there's 1, 2, 3 time intervals between these 4 drops, which means since they're equal time intervals, I could just simply divide by 3 to figure out how much time each of those drops are going to take. So t divided by 3 here will equal 0.213 seconds, and so that's how much time is in between each of these drops. So now, if I want to solve for the second drop, since this is, again, is the first drop, this would be the second drop. And we can see that from the top to there, I have 2 time intervals that it takes to get there. So my time is going to be 0.213 times 2, which will equal 0.426 seconds. So now I'm going to go through and I'm going to try to figure out what is my distance when I have dropped this far. So x is my final distance that I'm solving for. So x minus, and again, I chose my x not to be 0, and so I'm going to keep that there, and that's why I chose that, because I knew that'd be a little bit easier with my calculations here. And so again, my initial velocity is 0, so I plug in the 0 there, plus 1/2 times -9.8, but now I know my time. I know that it's been 0.426 seconds to get there, so I'll plug that in, 0.426. Don't forget to square that. And then from here, I'm going to find out that my x is -0.89 meters, which tells me that I am 0.89 meters below where I started with this second drop. So lastly, I'm going to do my third drop, and for that one, I've only been dropping for just 1 time interval, so 0.213 seconds. So I'll do the same thing. So I have x minus 0 equals, my initial velocity again is 0, plus 1/2 negative 9.8. And then my time again is 0.213 squared. And so this distance right here is negative 0.22 meters. And so we are just we're 0.22 meters below the nozzle. And we did it.